6-4 was adding matrices, subtracting matrices, and then we did a little bit of multiplication of matrices. And there's two kinds of multiplication. There's matrix multiplication, and then there's actually multiplying two matrices together, okay? This matrix right here, it's rows by columns, okay? So this matrix right here would be a, what kind of matrix? 3 by 1. This matrix here would be a 1 by 3. Okay? When I multiply these two together, okay, two things. First of all, the two inside numbers must be the same, right? So these both have to be 1, or whatever number it is. In this case, they're both 1. So my new matrix is going to be the outside two numbers, which is a 3 by 3. Okay. Did you guys all understand that from yesterday? From the video, yes, no? Yeah? Okay. Now, I think in the video I showed you like how you could actually do the multiplication by itself, but I'm not going to expect you to do that. And so really, we can put this into our calculator, and we can put this one in as a 3 by 1. We can put this one in as a 1 by 3. We can multiply it, but I just want you to understand that the new matrix is going to be a completely different size, okay? These two are not the same size. They don't have to be the same size. When you do addition or subtraction, they have to be exactly the same size in order to do add or subtract. If they're not the same size, then you just say not possible. Cannot add them or subtract them. But when I multiply, the two matrices don't have to be the same size, but the two inside numbers must be. The columns on the first and the rows on the second must match up. And if so, then my answer is my outside two numbers. Okay? And so if you were to put this into your calculator, it should give you out a 3 by 3. And then that would be your answer. Okay? Questions on anything from yesterday, or especially, that was the real big one. And like on the test next week, I will allow you to use your calculator on one like that. I'm not going to ask you to do that by hand. But you're going to have to know how to plug it in. You're going to have to know the rule, okay? And in some cases, if this was like a 2 here and a 1 here, then you would just say not possible. We cannot multiply those two together because the two inside numbers do not match up. So it won't allow us to multiply them. Okay.
So they have to be the same outside number?
Inside number. The inside number. And then if the inside numbers are the same, then your answer, your new matrix would be the outside numbers, which would be the 3 by 3. Okay, questions on that or anything else from yesterday? Video made sense for the most part. I mean, a lot of it is just matrix stuff again, doing some basic operation stuff with it. Okay, today for 6-7, we're gonna, I'll say it, yeah, right? Funny, right? We're going to actually spend 3 days on it, so I won't say it 3 days in a row, right? We'll just say day 1, day 2, day 3. But today we're going to do our first day, and this is all about solving or graphing inequalities, and we're going to kind of take it another step each day. But today is going to be graphing inequalities. We're going to start with single or simple inequalities where all I have is one inequality, and then we're going to step it up to do multiple inequalities or a system of inequalities, and we're going to graph those on the same coordinate plane, and then eventually we're going to get into somewhere where we're going to have like 3 or 4 inequalities that we're going to put all onto the same one. And then on Monday and Tuesday, we'll get into doing some more stuff with each one of these, but there's a lot of different kinds of problems here. So, and because we have the time to spend on it, then we're going to take a little bit extra time and spend it because we haven't talked about some of this stuff for a little while. So I'm going to start off with just a real basic y is less than or equal to 3x minus 6. I'll put up some graph paper here in a little bit when we start doing more and more of these. But for this one here, it's already in slope-intercept form. So our slope is 3. Our y-intercept is -6. And then we're going to graph this one, okay? And we're going to graph it just like we've been graphing lines all throughout the semester whenever we have a linear inequation. We're going to start by going down 6. And then my slope is 3 over 1. So we're going to go up 3, right 1. Up 3, right 1. And I can do that as many times as I feel like I need to, just to get our line. Now, before we connect those 2 points together, we have to decide several different things. First of all, the first thing I have to decide is what kind of line do I want? When I start graphing inequalities, you have 2 options. It's either going to be a solid line like we're used to, or it's going to be a dashed line connecting them together. If we have an equal to underneath, then it's just going to be a solid line. Okay? If I have a less than or greater than symbol, then it's going to be a dashed line or a dotted line. So this one, we're going to connect it together with a solid line. And then we have to decide which way to shade. We're going to shade it either above or we're going to shade it below. Less than or equal to, as long as it's in slope-intercept form, less than or equal to is going to be below the line, greater than or equal to is going to be above the line. I know sometimes people have a hard time deciding, especially where the line is at, which one's above and which one's below. So one thing that you can always do is you can always plug in a point. The point that I always love plugging in is 0, 0. If I plug 0, 0 in to this inequality, the reason I like 0, 0 is because it's easy to plug in. 0 is less than or equal to 3 times 0 minus 6. So if I plug in 0, 0, I get 0 is less than or equal to 0 minus 6. So is 0 less than or equal to -6? Is that a true statement? No. Okay. That is not true. Okay. 0 is actually bigger than -6. So that is not the way we want to shade. If I said yes, this would be the side I would shade. And since I say no, this would be the side I have to shade. Okay? And you may not need to do that extra step of checking it when it's in slope-intercept form. What we're going to talk about here in just a second is when we do standard form, we're definitely going to want to check. And I'll show you why. But on this one, you might just say, okay, well, this is below the line, so this would be the side I would shade. And I just want you to understand what this means, right? So when we've been solving systems and we've been doing solutions, we're saying what points make this work? Well, because it's an inequality, obviously any point that's on the line would make this true, but also any ordered pair that's in this shaded region would also work. So like, for instance, 3, 0 would be a point that I could plug in to this inequality and it would work. So we have multiple answers that would work here, and we write our answer as a shaded region. And so throughout this whole lesson, the 3 days that we're going to be doing this, we're going to be looking at our answer as being a shaded region, not like an ordered pair. Eventually we'll look at some where they're going to cross, and sometimes the point where they cross is going to be a big deal, but not always. And so in this case, we just have a single line. So any point that's in that shaded region would be a solution. Okay, so the first one I gave you was slope-intercept form. This one is standard form. Both of these forms are forms that we've graphed a ton throughout the semester. We're in person. When we graphed out of standard form, way back when, we could solve it for y. There's nothing wrong with solving it for y and getting it into slope-intercept form. But a quick and easy way that we talked about graphing this is the cover-up method. Finding out where's the x-intercept, where's the y-intercept, and using those two to graph. Okay? And frankly, I don't necessarily care which way you graph it if you want to solve it for y. One of the benefits of solving it for y is I could use my calculator to help me graph it. I know some of your calculators, actually, you can put in the less than, greater than symbols, and it would shade it for you as well. Not all calculators, I don't think, do that, but some of the newer TIs, I think, you can actually do the shading on your calculator with it. But you'd have to solve it for y in order to do that. I still like the cover-up method here because I think it's a little bit easier. It's a little bit shorter way of getting a couple of points. You don't need a bunch of points to be able to graph a line. You just need 2. And so in this case, if I plug in 0 for x, 2 times 0 is 0, and this is why we call it the cover-up method. I'm going to cover up my x. I have negative 5y is equal to 10, essentially. And don't really worry about the less than symbol right here, because we're just solving it. And 10 divided by negative 5 would be negative 2. You do got to watch the signs, though, the positives and the negatives. That's the thing that gets really particular here, so that way my intercept's in the right spot. If I plug in 0 for y, I could cover this up. I have 2x equals 10. 10 divided by 2 would be 5. And so this would be 5, 0. So we go down 2. We go right 5. And there's our 2 points. Okay. Once I get to having 2 points, and you can do more than that if you want, but 2 points is enough, then we decide what kind of line that we want. Well, this has no equal to underneath. It's just less than. So when I connect these points together, it's going to be a dashed line, not a solid line. And all that means is that any point that falls on this line is not part of the solution. So like 0, negative 2 does not satisfy this because it's not going to be less than. Same thing with 5, 0. It's not going to satisfy that inequality. Okay, the one thing with standard form is if you graph using this cover-up method, then you have to check it. You've got to plug a point in. You don't necessarily have to on slope-intercept form, but when it's in standard form, you have to check it, and I'll tell you why here in just a second. But we're just picking a point. Any order pair will work. Any order pair you want to use. But my go-to is always 0, 0 because it's so easy to plug in 0, 0, right? 2 times 0 is 0. 5 times 0 is 0. 0 minus 0, still 0. That's why it's so easy. Is 0 less than 10? Yeah. So this works. So this would be the side that I want to shade. Okay? And this is where a lot of people go wrong, is because they look at the original inequality and they see less than and they think that they're going to shade underneath this, but you know, okay, you're actually shading above. Bless you. You're actually shading above. Here's why we shade above. Anybody know why this is shaded above and not below? They want to take a guess on why? What would happen with this inequality if we were to solve it for y? If I sign it flip, right? I would move 2x over here, and I would divide by a negative 5. And when I multiply by a negative 5, that makes me flip my sign. Okay? So whenever you have a negative in front of a y, that's actually going to make that sign flip. So if you did solve for y, you would have to make sure that you flip it and solve and flip the sign if you multiply or divide by a negative. Okay? So those will be the 2 most common types of graphs that you're going to see when we talk about linear. Slope-intercept form and standard form are the ones that we've graphed over and over again in those forms. The other 2 specific ones that we'll talk about here, y is greater than negative 3, and x is less than or equal to 5. So these are kind of like our special scenario type graphs. They don't have both an x and a y in it. They're still linear equations because they're going to be lines, but they're special types of lines. When it's only y with no x in it, as long as we know the x and y axis, it should make this a little bit easier. Y is greater than negative 3. So that means my graph, my line is only going to cross the y-axis at -3. And so what's going to happen here, it's going to go down 3. Okay, once again, solid line versus dashed line. This would be a dashed line. And it's greater than. Because my line is a horizontal line here, it doesn't have a slope to it, it has a slope of 0, then it's either going to be above or below, and this one's pretty easy. It would be everything above that blue line, and that would be my graph. So if I have only an x with no y, what kind of line is that going to make? It's going to be vertical. It's going to have an undefined slope. So we're going to go over 5. This time it's going to be a solid line because it's equal to. And when here I just think of like a number line. As I move to the right on the number line, I get bigger. As I move to the left, I get smaller. So in this case, if we're saying less than or equal to, we're talking about everything to the left of that blue line. So it'd be everything on this side of that blue line. So those are just kind of a couple of special scenarios with 0 slope and undefined slope that don't necessarily have a positive or negative slope to it. Okay, so now what we're going to do is we're going to do a system of inequalities. And this is kind of like what we did earlier in the chapter when we graphed equations. We're going to have 2 inequalities on the same coordinate plane, kind of like we graphed 2 lines on the same coordinate plane in the very first section of the chapter. Except now we're not looking at where do the lines cross necessarily. We're looking at where do the 2 overlapping regions intersect or overlap one another. So we got y is greater than x plus 1, and then y is less than or equal to 2 minus x. We got 2 inequalities. We're going to graph both of these inequalities on the same coordinate plane. We're going to shade them both, and then we're going to see where do they overlap. Okay, and there's a couple different ways that you can kind of approach this, but we got to go one at a time. And it really doesn't matter which one we start with. So let's start with the x plus 1, first of all. It's in slope-intercept form. My slope is 1, my y-intercept is 1, so we're going to go up 1, make a point. My slope is 1, so we're going to go up 1 over 1. And I can keep doing that as many times as I need to. Okay, it's greater than, so it's going to be a dashed line, and greater than is going to be shaded above that. Okay, I like to use different colors because I think it's easier to see the overlap region when I do it. So if you have different colors, that's great. If you don't, I'll show you another way that you can kind of go about it. On this one here, probably would be best to rewrite it in slope-intercept form. It will be written like this sometimes, and that's why I write it like that, is because they don't always put the x in front. And so sometimes that gets a little confusing, but if we just flip those 2 around and rewrite it as negative x plus 2, now it's in slope-intercept form. This is my slope, this is my y-intercept. We're going to go up 2 on the y-axis, and we're going to go down 1, right 1. And we can do that as many times as we want. We could also go up 1 and left 1 if I needed to, and go the other direction. You can put as many points on that line as you feel like you need to. Hey, this time it's going to be a solid line. Bless you. Connecting those all together. And you could check each one of these by plugging in 0, 0. But I think slope-intercept form, for the most part, is pretty easy to determine if it's above or below. In this case, we're looking for less than, so we're going to be below the blue line. So we're going to shade everything underneath the blue. And we're looking for the overlapping region. So my overlapping region would be where it's both red and blue. And that would be this area right in here. Okay, so this area is my solution. Your solution is not an ordered pair. Okay, your solution is a shaded area. And what we're saying here is any point that falls in this green area right here would satisfy both of these inequalities. It would make both of those work, okay? And so that's how you could check it if you really wanted to check it. Not that we have to or would, because that would take a little bit of time, but if you're feeling like maybe I didn't shade the right way or something, you could always check it by taking any ordered pair. There's tons of ordered pairs that would fall in that green area. Okay, questions on that one? You guys kind of all remember doing all this, don't you? I'm going to do this one in blue. I will do some with some graph paper here in a little bit, especially the ones we do next week, because the accuracy with the graphing is going to make it important based on what we're going to be doing. For today, not as big a deal because we're just graphing and shading and not quite as big a deal. Okay, both of these are in standard form. So you have a choice here. Okay, neither one of these would be real hard to solve for y. This one would be really easy, just subtract x. This one, you could add y and subtract 2. What you'd want to be careful of, though, is your sign, if you do it that way. So like, for instance, on this one, I could subtract x, and I get y is less than or equal to negative x plus 1. It's not a big deal, okay? Over here, you could subtract x and divide by negative 1, or what I think's maybe even a little bit easier is I could add y over here, and I could subtract 2 over here. Now, the part here that you got to be careful of is there's your inequality. And usually with inequalities, what we would rather do is leave it with the y on the left, okay? And that's why it might be better just to solve for y and leave y where it's at. But if you do move the y to the right, then make sure the sign still opens in the same direction. I flipped everything, so I got to flip the sign as well. The reason we want the y on the left here is because then this symbol tells me it's going to be greater than, it's going to be above. Okay? If I left it like this, you might look at this and say, oh, it's less than, so I'm going to be shading below. So finishing with the y on the left is usually a pretty big deal as far as the shading part of it. Or you could have done the cover-up method as well. So we have lots of options with what to do here. For the first one, we're going to go up 1. My slope is negative 1, so we're going to go down 1, right 1. Okay, and do it as many times as you want. It's going to be a solid line. And then less than means it's going to be shaded below. Okay, for the second one, if this is the one that we're going to shade, we're going to start by going down 2. My slope is 1, so we're going to go up 1 over 1. It's also a solid line because it's equal to. And we talked about the symbol being greater than, so it's going to be shade above the blue line. Hey, and how you represent your ink. So like if you don't have different colors, I get it, that's fine. But if that's the case, then we would just want to make this area like a little bit darker so we know that this answer or this area right here is my answer. Okay, if you have other colors you want to use, you can do that. However you want to do it. So, some people wait to shade until the very end and they say, okay, I know the blue line's above, I know the red line's below, so then they only shade this area here. Okay, and I don't have an issue with that either. If you can kind of visualize it and say, this is the area where they're going to intersect. So a lot of different ways that you can go about the shading, but somehow you have to show me that this answer or this area right here is our solution. Okay, especially like on a quiz or a test, we would want to make sure we show that area. Okay, the next couple here, I'm going to put a piece of graph paper up here because I think it'll be a little bit easier to do. We're going to have 4 inequalities. So we kind of keep stepping it up a little bit here. 8x plus 5y is less than or equal to 40. X plus 2y is less than or equal to 8. X is greater than or equal to 0, and y is greater than or equal to 0. And I think for this one, I'm going to go without a graph paper. I think this one will be a little bit easier to do it, and I'll show you why. When I graph these two right here, what does that restrict me to? Where am I going to be at? Where does my shader region have to be? If x and y have to be greater than or equal to 0. What's that tell me about x and y? What kind of numbers will they be? Positive, right? 0 and above. They're going to be 0 or they're going to be above. So when I think about a coordinate plane, where would I be at if everything has to be positive? Upper right, yep, quadrant 1, right? The very first quadrant. And we're going to do some, where we're going to do some problems like this as we go throughout this lesson, the next couple of days next week. Rather than doing the entire coordinate plane, because this one is restricted or limited to the first quadrant, then I'm only going to graph the first quadrant. If you want to make the whole coordinate plane, that's fine, but just know that you're not going to have anything on the other part that really matters. This is the only area that really matters, because if x and y have to be greater than or equal to 0, and you'll love hearing this, I know, but the reason we would do something like this would be if we have like a story problem. Okay, so that kind of gives you a heads up of where we're going to be headed eventually, is we're going to be doing some problems like this where we're going to have a story or a situation that applies to this, that we're going to write some inequalities that represent it. All right, so x and y greater than or equal to 0 restricts me up here. Okay, so that's really what these two are telling me. For the other two, because they're in standard form, I still think, and unless you really feel like you want to put it into the calculator, putting it as a cover-up method would be the quickest and easiest way to do it. I'm not saying that you can't solve for y, but I'm just going to do it by the cover-up method, and I'll show you why it's a little bit easier. If I plug in 0 for x, I have 5y is equal to 40, so y would be 8. If I put 0 in for y, 5 times 0 is 0, so I'm going to cover that up. I have 8x equals 40, and 40 divided by 8 would be 5. Okay, so if I graph this one, five, 0, 0, 8. It's going to be a solid line. And I'm not going past the x and y axis because what we talked about is that really doesn't matter. We're limited to staying within that first quadrant. And so we're just going to connect those two intercepts together and stay right there. Okay, and we're going to do the same thing for the second standard form inequality. Once again, I'm going to do my x-intercept and my y-intercept. If I plug 0 in for x, I get 2y equals 8. 8 divided by 2 is 4. If I plug 0 in for y, cover it up, I get x equals 8 because there's nothing to divide by. So this would be 0, 4, 8, 0. Solid line. And then we got a shape. Okay, both of these are less than or equal to. So 0, 0 satisfies both of those lines. We also said x is greater than or equal to 0, y is greater than or equal to 0. So my overlapping region would be this area right in here. The x and y axis are closing it in, and then the red line and the black line are closing it in. So what we ended up getting here is we get a enclosed figure by all of those different inequalities. Okay. And we're not going to worry about it for today, but leading into what we talk about on Monday, we're going to find those 4 points that enclose that region, and we're going to use them to do some things with them. But we don't need to worry about that today. Today is just doing the actual solving and graphing of them. All right, so that one I think is pretty straightforward, and I wanted to do this one because this is something we're going to see a lot, especially as we get into some story problems, because we're going to say we have to have a positive answer. And then the two standard form equations would represent something if it was a story. Okay, here's the last one we're going to do today. This one I'm going to pull up a piece of graph paper because I think it'll be easier if we do. So I'm going to pull up a piece of graph paper real quick. Find a good piece to use here. Okay, kind of like the last one. I'm going to give you a group of inequalities. This is going to look pretty similar to the last one that we did. We got 3x plus 4y is greater than or equal to 12. 5x plus 6y is less than or equal to 30. And then this one's going to be a little bit different. 1 is less than or equal to x is less than or equal to 3. And we could see one like this with either the x's or the y's, but this one's x only. And if I gave you, let's say I covered this part up right here. If I said x is less than or equal to 3, what kind of line are we going to have? Solid. Okay, solid line. And what else? Vertical. Okay. So it's going to be through the x-axis at 3, and it's going to be a solid vertical line, okay? Same thing here. This is really saying x is greater than or equal to 1, because x is on the right, right? And so if I rewrote this as two separate inequalities, it would be x is greater than or equal to 1, and x is less than or equal to 3. This is a compound inequality, okay? And you don't necessarily have to rewrite it, but this is what your graph, I'm going to start with that one first. This is what your graph is going to look like there. They're going to be a solid line at 1, and then a solid line at 3. And they're going to be vertical lines. Okay? And right now, it would be everything in between those two black lines. I'm not gonna shade it right now. I'm gonna wait to shade it here until just a second. But just to visualize, and it's gonna be everything in between. X is somewhere between 1 and 3, is all we're saying, okay? The other two, I would do the cover-up method for. So when I plug 0 in for X, I get Y is 3. When I plug 0 in for Y, I get X is 4. It's going to be a solid line. Looks like that. Okay. Now, once again, I'm going to wait to shade this because we got so many lines going on here, and we'll see what's going on here in just a second. But if I were to shade this one greater than or equal to, if I were to put 0, 0 into this equation, is 0 plus 0 greater than or equal to 12? And we would say no, right? And so that tells me right now we're above the blue line, okay? So we're above the blue, we're between the black. Just kind of keep that in mind as we do this. For the last one, once again, cover-up method. When I plug 0 in for X, I get 6Y equals 30 essentially, and then 30 divided by 6 would be 5. When I plug 0 in for Y, 30 divided by 5 would be 6. So we have 6, 0, 0, 5. And it would also be a solid line. And what we now see is that the red line and the blue line are what? Parallel. They're never going to cross one another, okay? If I plug 0, 0 into this guy, 0 plus 0 is less than or equal to 30. That is a true statement. 0 is less than 30. So we're going to be above the blue, below the red, between the black. So my shaded area right here would be this little area right in here. Okay. And that little green area would be our solution, because that's where all 4 of those inequalities would be shaded at. Okay. Anything that falls within this little area right here would satisfy all those inequalities. Little parallelogram. Okay. Like I said, Monday and Tuesday, we'll continue with 6, 7, and we're going to keep doing more and more with this, okay? But for today, we're going to stop right there. Okay, so some of these are single inequalities, some of them are multiple inequalities, all of them are graphing and shading. That's the one thing they all have in common. That's how we know when to shade, is when we have an inequality. Anybody want some graph paper?
Mr. Neal traded me half of the game for this. We were up 9-4 after like 7.5 touchdowns. He traded me. And he traded me half.
If you want graph paper, I got some sitting over here.
And we almost got
grab
back.
some.
It was like 10 to 12.
Are they sure? Right.
Yeah, sorry.
I didn't try my homework. I was very high yesterday, so I remembered.
Yeah, TT came with his
I can't be there. I'm taking pictures of It shouldn't take that long.
Yeah, sure. I likely still.
Why does he, and why does he
Huh? Why is he still stuck? Yeah, he dabbed me up after.
He was your coach? You're on my team?
No, he dabbed me up after I actually threw in the ball on his face. Yo, that's that was long from me.
That was 3 feet short.
The front of the rim, because I got the rebound. He went to finish out like
Yeah, Jerry was pretty good.
Here's the best part of the game when he played.
It was just 8 to 11. It was just like, you could put that in. And he was just, we didn't know he was like, what are you doing? He goes, oh, I love my
I was spinning. I was the fastest sprint while doing this. I was spitting balls.
Yeah, the Kobe. Kobe made you I sent you an Eze, Bryson, Nixon, and Zach.
So does that tell you why we can I like taking sides. I think people just don't like yeah. So that's that.
Turban, yeah. I don't know. I love when it falls off.
He's like, I can't see him, but I'm like, just cut you.
See you guys, have a good weekend. I saw that.
Just as a reminder, all of Mr. Gazaway's classes will be in the library today until further notice. So if you have Mr. Gazaway for third hour, please make sure you make your way to the library, not to his classroom, but to the library. Mr. Gazaway's room goes to the library. Boys' locker room, freshman boys' locker room, please just meet in the old gym. Please meet in the old gym if you're going to a freshman boys' PE class other than health.